All right, guys. So we're going to start with what we have for today on the C series, study series. So this is our agenda for today. We are going to review our assignments and then we briefly look at the concept of thinking like a programmer. And this very concept here is actually I actually put it there, especially for the majority of us who are new to programming and who are generally new to programming languages. Okay, so that's because I'm very sure, pretty sure by next week things could become very overwhelming and we don't really need to be discouraged. When our mindset is positioned very well, we will move. So all that is necessary. The truth of the matter is a lot of study is demanded. Part of the requirements, you have to study, you have to read. Okay, so on this thinking like a programmer, there are some concepts about programming language, especially when you are new to it, that we'll talk about. Then we'll move into variables and constants. Okay. After that, we have reviewed our assignments. Okay. Then after that, we will move into what data types are. Okay, so like these are like the foundation. Then we'll move into performing some operation with variables, of which I think we touched some part of it the last class. Then we'll go to intro to printf and then performing some little operation with printf. After that, we will go to intro to scanf. So we are not going to take much time. We're going to be breaking it bit by bit, especially for to really get the foundation. The foundation is what we are trying to build. So it's not a thing to rush, you know. So it's a thing to really just ensure that we get the foundation. Once the foundation is strong, the next thing is to build upon it. So as we had the last time, we talked about programming language, programming programs, and what who a programmer is, you know. Then we talk about classes of programming language. Then we talk about translators. No, all of these things are basic knowledge that are necessary in order to at least get going, so that when they come, when you see them, you won't get overwhelmed. Okay, so we talk about the C language itself and where we stopped and where we buttressed enough points was on the basic structure of a C language, of which we were able to pinpoint some very important sections. Even though we outlined or listed out 6 sections here, and some could be optional depending on the type of program, depending on what your program is going to solve, the problem your program is going to solve. But we were able to touch really all of these 6 sections: the documentation section, the link section, definition section, the global declaration section, the main section, and the subprogram function section. Okay, so and we're going to start from where we stopped again, starting with that. So I believe everyone has actually created the repository we asked on our GitHub page, because we will be doing, especially like our assignments will be based on interacting with Git and GitHub. This is really to prepare us and really to get us familiar that we are going to be using the terminal to do our project with VI to write most of all the sections. So it is necessary that we get familiar with them, especially for those who are new to programming or for those who are new to this. It's going to be very overwhelming at some point. I have to be truthful, but we really need to what the earlier we prepare, the earlier we understand what is coming, the better it is for us to move. So then we talk about Replit, where we are going to be using it for most of our collaboration. That is where everyone can be invited to perform a task at the same time in real time. Okay. Okay. So let's us move on to the assignments. But before the assignments, can I through a I have actually even spoken on what we did the last time, but at the same time, we are just trying to interact a bit. So probably I will call in you so that we can make it um we can make it interactive and then use the time. It could be like a revision. By tomorrow, we are going to dive into something very special, like all of the if I will be moving faster now, and strength is available already by the grace of God. Like before the C comes by next week, all that will come, we are going to already get familiar with them, so it will become very easy. So I'm going to throw a question. The question is going directly to Kemi. So, like our last class, I believe she was available. You were around. So, what can you talk about? What can you talk about? I don't even know what to ask. Okay, can you just talk about the difference between a compiler and an interpreter? Okay, let's start from there. Like, what do you understand by a compiler and an interpreter? And let's just start with that. Let me don't bore you with too much questions. Okay, the floor is open. The mic is open. Compiler, interpreter. Hello. That this is going to be interactive is going to help us to really see how far we are going with this and to show that these meetings are productive. Okay, we don't really want to talk, just talking. I'm a student,
Okay.
you're a student. Yes. Okay.
Okay. Based on what you shared last time,
Okay.
according to according to your definition, right? A
Okay.
compiler translates source codes to object codes
Okay.
and then machine codes,
Perfect.
while an interpreter translates source code line by line.
Perfect.
Yeah, that's what I
100%.
remember.
Okay. In fact, I'm clapping for you. That's very nice. Thank you for
Thank
the
you.
response. It's
Okay.
really goes a long way. Okay, I really want to like ask this question again to you, but I will direct it to another person and then let's just move. I just need us to just say some things. Okay, I'm directing this question to Bisola. So, can you give an example of a compiled language, that is a language that uses compiler as its translator, and one example of an interpreted based language? Okay, that is to Abisola. Hello.
Hello. You said
Okay.
example of what?
A compiled type language, that is a language that uses compiler as its translator. One example. And another example of the one that uses interpreter as its translator.
Okay. C programming. If I'm right. I think
Okay.
C. And for interpreter. Ah, I'm not sure, but I think Python. I'm not sure. I can't remember you touching that topic. I can't remember. I know that, but I know that C language uses compiler. But I'm not sure if I'm right about interpreter.
Okay.
Please correct
Yeah,
me.
C language is a compiled language. This is a compiler. You are right. And yes, you were not sure about Python as language that uses interpreter, but yes, it uses interpreter. So examples of a compiled language, we have C, we have C++, we have C sharp. We example of an interpreter based language, we have Python and we have JavaScript. As based on the examples that I gave, you can see them. So interpreter based language, Python, JavaScript, PHP, Ruby. Okay, that's about that. Then last question, I think I've already opened the answer. multiple times. That goes to Sheriff. So it's just a brief quiz. Can you just like name like four sections, four very important section of the C language, of a typical C language, four sections that must be present if you're writing a C language, starting from the most important ones. Okay, the floor is open.
Okay, so it means I don't have to mention the comment section. No? Okay. So the header section, I think, and then
Okay,
the
one.
the global declaration, the
Okay, two.
main the main function, the main section itself.
Okay, that's three.
Then okay, this part where you have to define if you want to.
Okay, definition section for
Yeah,
macros.
definition, yes. I
Okay,
think
I think
that
we
is
are
for
good to go. Okay, thank you all for your responses. It goes a long way that we have learned something in the past few in the past lesson, in the past lecture. So let us start with our assignments. We give an assignment, and I'm going to invite us in.
I didn't do my assignment too.
In fact, the assignment is good. Is to be done here.
It's for
Okay.
both totally.
So we are going to do it together. I'm going to invite us now.
okay. I did the assignment, but I later found out you gave us what was it called? Particular values for our variables.
Values for it. Okay, you actually just
I just
particularize it.
like typed the whole thing. It was I think this morning I saw this, but I was too busy to come back to
Okay,
it.
okay. You didn't make use of these values. Okay,
Yes,
okay.
but
But okay, let's
doing the assignment.
interact. Okay, let's interact now. I'm sending the link to us, so everyone should come in so that people that will undo every of the section. We are, I think one person has left, probably network or engagement. So we are three. We should be able to undo the assignment. So it is a C program that calculates the average, sorry for the typo, average of five numbers. Okay. So, and we have been given variables, variable num1, num2, num3, num4, num5, and then average. So the values for each of the variable for num1 is equals to and num2 15, num3 25, num4 10, num5 13. So we are now asked to calculate the average of five numbers, of these five numbers. One very thing that ALX will always try to remind us, and one of the very, very key skill required for every programmer is the ability to be able to understand problem that we want to solve. We could see that this problem is very basic, is very probably simple to understand, or probably we can see that okay, this problem we can tell the answer by just looking at it. But that is not enough as it is of like it is not enough as it is required of for being a software engineer where we want to what automate it. Okay, probably want to create a software, an application that will what be calculating average. So now it is not something that is very it is not something that we can just say the answer that requires us to just say the okay, five numbers average is this. We need to what create a pattern, we need to create a system, we need to create a logic that is going to that is going to do or perform the actions. So it is a thing of which we want to create set of instructions for the computer to what to always carry out. We want to automate. And now we need to understand that we are what dealing with a machine that what has a particular language that it understands. So in that point, we need to understand that okay, for a particular language that I'm going to utilize, for a particular language that I'm going to use to automate this system to perform these tasks, I need to understand the language, the culture, the syntaxes and the semantics and every of the acceptable strings and operator for that language. C, for example, it has its own language. It has its own language symbols. It has its own syntax. It has its own semantics. It has its own operator. It has rules. Okay, I think the general word is to understand the rule guiding acceptable operations on that language. So after that, we now need to understand the problem itself, how to break it down. After breaking down the problem, we need to now understand how am I going to what are the needed materials. It's just like doing a project whereby you need to break it down into identifying the needs. Okay, identifying the needs for that project, human resources, and what financial resources and intellectual resources and every resources that is needed. Now, to calculate an average of five numbers, we need to understand that okay, five numbers average, we need to understand what average is and how it is being calculated. Then after that, we need to understand that okay, five numbers, then these five numbers, we need to have them available. After having them available, then their values was we need to know what their value is, or we need to always know what their value is in order to perform the operation. So all of these factors are just like even part of the things that is going to be covered in the aspect of thinking like a programmer. So now for C language, we've understood this basic structure of a C language, which we talked about the last time. That is, in order to write a language in C, such that when we run it, it will what? It will give us results. We need to understand the acceptable structure of which we talked about the last time. Before this, we talked about the comment section and so on and so forth. Now, just to quickly dive into what we have for today, some persons are already coming in. So now we are going to practicalize this now. Now for this average of five numbers, I think that we understand in mathematics the formula for calculating average. That is the total number of value divided the addition of the individual value. Sorry, so summation of individual values, sum n, divided by total summation of what of the given values. Okay, so when we say addition of individual value, addition of individual value, that is num1 plus num2 to num n, whatever this thing it is being given, whatever range. So num1 to num n divided by the total what quantity, probably that should be able to that should be explicit, of the given value. So it is what five numbers. So I think that is what the basic logic. I should be writing this with like a pen, but I don't have that. So I'm inviting us now. Let us begin. We should join the link, please. The link is on the chat. So let us start now. In fact, we're cleaning all of this. So I'm dedicating the comment section. Will go to it is Tutu. The comment section will go to Emmy. Okay, and then the header section will go to Bisola. Then the declaration section will go to Sheriff. I'm taking these easier parts, of course. And then the main section will go to myself. So what we are trying to look at here, we are trying to ensure that we get familiar with all of this, because I will repeat myself. When we start the C on the VI, we are going to start with every of these things. We are going to write it from scratch. When I open the Replit, all of these things were like there automatically. Although we will move to that section soon, but we need to get familiar with it and be able to what interpret, explain every of the individual sections. Aside when the program becomes bulky, that we don't have time for that. We really need like a brawler template. Okay, when you say a brawler template, the sections are already there. You just need to start coding. So let's get to work. Please, let's come in. I've not seen anyone get in with the link. I have shared the link on the chat. Okay, so let's get to work. We are starting from line 6.
Please share on WhatsApp, please.
Okay. I've shared. Let everyone get to work. I think my own section is even the last one as far as this project is concerned. So,
Yeah, please give me a few seconds. I'm trying to log on to my laptop.
okay. Okay, Bisola has joined and Sharif has joined. Wow, this is even good. We can have up to 100 persons. So you can just start with your own section while every other person comes. So I think I'll just start with mine. You can, so if you are starting your section, you have to start it above mine. Okay. Okay. So if you have our notes, we can check our notes. There's no harm in trying to see the resource. It's just for us to write it so that it can become part of us. We know these are just basic, but it is from basic we go to advanced. Okay. The header section is yet to be done. The declaration section. What's happening? Hello?
Sorry, I will join soon. I'm attending to my boy. Please, just give me a few minutes.
Okay. Okay, let me open the structure again. So probably we need to see. So this is the 6 sections. So can use that as because we are born in time. Okay.
Okay, hello. Sorry, declaration. Do we already have them? Do like do we have Okay, let me confess. I'm sorry. I'm actually doing something, working sort of. So, what is it I'm
Okay.
supposed to do?
So, okay, we have the variables already given to us according to the assignment.
Okay, these
So
ones. All right.
we have to declare the variables. Okay. Probably before anyone start. Okay, please, let's pause. Let us try to see, let's write the pseudocode. I'm going to clear all this. I think I'm going to clear all this. So let's try the pseudocode. And like we call it pseudocode and algorithm to calculate average. So we need to understand it. Average of 5 numbers. So we have the given numbers, and we have num1, num2, num3, num4. I haven't stopped at num3 safe. Okay, and num5, but it's good to go extra mile. Okay, so what else is on your assignment? We have the values given to each of the variables. Two, 15, 25, 10, 13. Okay, so let's make it interesting. So num2 is 15, num3 is 25, and num4 is 10. So we are trying to get this pseudocode and algorithms that will solve it, because that is even the very first step. If we are doing things rightly, like a programmer, like a software engineer, not even programmer, anybody can become a programmer.
Giving numbers.
So we have the given numbers, yes. Okay. So now what do we need? Firstly, before we start even writing the step, like pseudocode step 1, step 2, all of that, what we need to understand how to calculate average of given numbers. Okay. And I was trying to explain a logic the other time. Average is based on my own understanding, individual addition of individual.
Summation, summation of all numbers divided by the total number.
Okay, I think that's a more technical term. So summation of
Oh,
individual,
yeah. Or you say variable, anyone. I didn't think I did.
okay, numbers of variables, that's good too. Okay, then divided by
The total number.
by the total numbers. Okay, so we could get the logic now. So now how do we implement it? So step one, what can we start? How can we do it now? So let's do the pseudocode together. So I think this is even the best way. If you can achieve this as understanding, it's very best as one of the key skills needed to thrive as a software engineer and probably going into C. So creating the pseudocode. So step one, what do we do? What do we do? Looking at this, we have the numbers given to us, even with the name and then the values. So how do we go about it? What should be our step one? Let's say step one, I'm going to give that we are starting. Okay, step two, what do we do? Anybody can, your pseudocode can be your own. You don't really need to follow a particular convention because there's no defined convention that it must be like this. Okay, so even what I said step, but it's always good that you put it in step so that you can now transfer it from actual English based on your understanding into um, the code itself. So step one, we start. Then what do we do? What do we do next?
Declare variables.
Declare. Wow, I like that. The variables, right? So
Yeah.
there's two things. Is a crash course. Declaring variables is different from initializing variables. When you declare variables, you just say let A, let B, let C, or let there be A, let there be B, or creating A, creating B. When you initialize variables, you are now giving them values. You now say let A equals this, let B. So I'm just giving that as an int. Okay, so step two, declare variables. Then what do we do next?
Then I think, like what you said, initialize variables. Since
Okay,
we
step.
have numbers assigned.
Okay, initialize initialize variables. No need to complicate it. Variables, am I correct? Am I not spelling it well? So what's the next thing? Step four. So we can be practical. So step one, declare variables. So we have num1, num2, num3, num4, num5, and then average, right? So initialize variables, we can now say, excuse me, please. Initialize variable, we can now say num1 equals the value,
So,
2. Okay, please call it num1 equals 2. But let me make it another line just to make it neat. So num1 equals 2, num2 equals, that's what, 15, num3 equals 25,
25, okay.
num4 equals
10
10, and
and 30.
num5 equals 13. Okay, so we have initialized variable. So now step 4, what do we do?
Add the numbers.
So add,
Uh, add the the total number of variables.
okay, add
No,
the,
sorry.
mhm,
Sum up variables.
okay, sum of,
Sum up. Oh, sum up. Yeah, you're right. Sum of individual variables or something. Yeah.
okay, okay. So separate is that, what are you telling me?
I don't know.
Please, oh.
Okay. Abi.
Okay, sum of individual variables. Now step 5, what do we do?
Get the average of the sum.
We are now saying calculate
Yeah.
average of the sum. So we have to specify how the calculation is to be, like making our algorithm explicit. So we can now say average equals what? Sum of variables divided by total number of variables, right? which we can now make it explicit again. We can now even say average equals n1. You can shorten it, value of n1 plus n2 plus n3. Okay, num1, we have to be consistent. That's one of the features of algorithm. Num3, num4, num5 divided by total number now 1, 2, 3, 4, 5, 5. Although when we do, okay, let's by the side. By the way, sometimes let's just move on. I don't want to complicate things. So we can say it like this, right? Are we on the same track?
Mm. Yeah.
Okay. Then what do we do? Step. This is step 6. This is step 7. What do we now do as we move on with our query?
This
We've
one is
gotten
step
the
5.
okay. It's supposed to be step 5. Sorry. Yeah, step 6. So we've already given the logic to calculate the average. So the next thing to do is
To
we should
print.
print. Yeah, good. So print the average. Okay, and can stop or end the program. So even here we can also choose to print the individual variables. That's optional. Like trying to construct a string, like saying average of num1, num2, num3, num4, num5 is, setting it into what? Average. I could say this is like optional, but I'm just trying to, you can see that. So no, no, so the very big achievement here is we have our pseudocode already, right? I'm going to cut this out, or copy it out, and we use it to solve the problem. Normally, we could have pseudocode. This our pseudocode is in 6 steps. So we could create it to be in 3 steps. We could create it to be in as many steps as possible. Okay. So what matters most is to understand what we are doing. So guys, I think we should get to work right about now. Somebody left. Let me see. I think that's Abisola. Okay. 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 Welcome back, Ramotamo. I think you are going to take the place of Abisola right now. She is to. Okay, can I ask, were you available? Were you around in the previous class? Hello, Ramotamo?
No, I wasn't around. I was having the same issue. The laptop was
Oh,
heavy.
oh,
It
oh,
was going
sorry.
through updates tonight. So yeah.
Okay, okay. Actually, we treated C program. We started our C programming series, so we talked about a lot of things. But I shared the live session that we did, so probably you could go back if you, or if you mind, to check some concepts. And then we had an assignment just to quickly push us even to new stuff, and then to get our hands into C as much as possible. So the assignment is to calculate average of 5 numbers, the values that we are given. So based on what we learned the last time, we did this addition of two numbers. Okay, so we are using that knowledge to just move on. I know that majority are new to C, and even some of the concept that we are using right now, we might be somehow new, but we really just want to get us doing something so that sometimes we might not really know what we are doing in the first place, but when we now get to that bridge, it will look easier. So what we just did just now was we created the algorithm that is going to calculate the average of five numbers, which we were able to successfully create. So we had all the step and we got into six step. So, and we have been able to share every of the tasks to each person. So Kemi, you can see she's already writing on the screen. She's writing the what are they calling it? The comments. She's assigned to do the comments, and then Abisola is back. Okay, Abisola is to write on the header, and then Sheriff is to work on the declaration, and I myself am to work on the main section. So moving to our recapping our previous class, we talked about the sections for the C program, and then we talked about six sections, which some of them are optional and some are very compulsory, which we noted out. Depending on what you are you are writing, depending on what you are programming, depending on the need of your program, some section might be optional, some might be important. So that is what we are trying to ensure that we recap, ourselves, and then we move on to what we have today. So that's about that. Okay, I could
Okay, thank
see, yes, I could see Bisola doing something. Do we really need math.h? Let's see. Okay, continue. Just continue, please. Don't mind me. I shouldn't have said anything. Well, Chem is really up and going with all the variables, declaring them.
So what do we need?
Okay, I could see something that Kemi introduced, which was not even part of the variables, and I think I like that. She's creating a separate variable for sum, which is going to be the addition of each of the individual variables. So that means at the long run, to calculate the average, we are going to be doing sum over total number instead of num1 plus num2 plus num3 to num5 all over total number. I think that looks cleaner. Okay. Okay, Bisola has actually included the necessary parts. Yes. STDIO. Okay. Yes. Okay. Sheriff has finished his declaration already. Let me then come into mine. So okay. So I think let's move. That's very good one from everyone. Okay, so we have the variables declared. We're following our algorithm, okay, as a guide. We have started, we created the comments of what this program will do, and we have declared all the variables. So sum is going to come in. Okay. So the next thing is to now initialize the variable, step 3. Okay. So guys, we can initialize the variable from above while declaring them. We can choose to initialize them inside the main function, inside the body of the main function. So let's choose the second, initializing them inside the body of the main section. So I'm going to do from num1 to num3. Now, okay, let me just go. So num1 is equals to the value, which is 2. Then we terminate it. Num2 is equals the value, which is what? 15. Num3 is equals 25.
25.
So Ramosamo, can you join the, oh no, you have not created the link for Replit. Okay. Okay. Oh, someone did something very, very interesting. I was actually waiting for that to happen, like an error to occur. So okay. Somebody declared a float. Hmm. Okay. So um let me see. Kemi is done with the comments. Okay. Let me just declare let me initialize all the variables. So number 4 is um, 10, and number 5 is 13. Now, okay, okay. Number 5 is missing here. So this error is cleared out. So we've initialized the all the variables. So we are still in the point of initializing. So now we need to what? Calculate the sum of individual
We,
numbers.
sorry, Mike, we under the sheriff's part, we have number 4 showing up twice.
We have, oh, thank you for that. Okay, okay. Oh, okay. So I think we are good to go. Okay. So now our algorithm back to whiteboarding. We have initialized the individual variables from num1 to num5. So the next thing is we have to calculate some of the individual variables. And we have a variable that is called sum, which is going to do that. So I think Kemi will do that. Kemi, we have to write the syntax that will do the sum that should be inside the main function. Okay. So and somebody should have scolded me for my main function. It is not complete. We have to return a value. So Kemi, assign value for sum. Okay. Okay. It's going to be after num5. Okay. Perfect. So we have the step 4 solved out. So we have the value for the sum given. So the next thing now we have to calculate the real logic here, the average. So it is more of like assigning value for the average to be calculated. So um Abisola, you have to do that too. So do the do step 5, which has to do with the calculation of the average. The algorithm is on the screen. Okay. Okay, nice. So Abisola, you have to do the step 5 based on our algorithm, calculating the average. So assigning value to average. Average has been declared here as AVE. Okay. So we are now to just do the same way like sum. Okay, Kemi is doing that. Okay, perfect. But there is variable name mismatch. What was declared here is AVE. Okay, so this is step what has been cleared. Step 5 has been cleared. You see, one of these things, as basic as all of this look like you can just run it once, don't do step. It's really, really necessary because you will need an algorithm, you need flowchart, you need all of those pseudocode to really solve big problems. And it starts from all these smaller ones. You can see we are actually just going to the pseudocode every bit of the time. It's just for the fact that we really want to imbibe a particular skill, mechanism, character, mentality, so that we can always solve problem like this. We are still on the preliminaries actually. So now the next step, step 6. Okay, so I'm going to do that. So step 6, we want to print the answer. So we are going to be using the printf function to print to the output stream. So we should understand that the printf, when we get to printf, we will understand more, but just a crash understanding. Printf receives strings of character. Okay, it can receive any string, can receive characters, can receive floating points, can receive um, integers, and so on. When we get to data type, everything will become clear. So, but we have to enclose it in a string, which is this double quotation. So we are now going to say the average of n1 of num1, num2, num3, num4, and num5 equals, then we'll give you the value float. We are using the specifier float f, but we are coming somewhere, we are going somewhere. Okay, we can now say, let's use to printf function. We can say printf for the first one. Okay, and num1 equals %d. Remember, %d is to capture the actual value of the given string or variable. So you can say num1 equals %d, num2 equals %d. %d means we are capturing integers. Num3 equals %d. Num4 equals %d. And num5, you can put the and there, it's just a string. Num5 equals %d. Okay, and we are adding a new line. Then we have to reference each of the variable, that is num1, num2, num3, num4, num5, according to the sequence. So it collects sequence of strings 1, 2, 3, let me put space here, 4, 5. It is going to print this statement according to how it is given here. And with the percent whatever, it is going to reference it according to the values what's given. So close the statement, terminate it with the terminator. So we can now move on to the second printf. That means it is going to print 2 lines. So the average of num1, num2, we can say num1 plus num2 plus num3 plus num4, so equals percent %f, of which we are referencing percent %f to be average, AVE. That is why the percent %f is for floats. When we get to data type, we understand what float means. So float is a type of data for numbers with decimal points. Float is a type of number for numbers with decimal points. We have another type of data that holds decimal values too, which is called double. So basically in C, we have data type which are like, we can group them into numbers and characters, okay? But when we break down numbers as type of the data type, you can now have integer, you can now have floating points. Integer are just whole numbers without decimal. Floating points are the ones with decimals. And then you have double too, that is the classes of numbers which are data type. Integer, float, and double, okay? And then when you have the classes of characters, you now have single characters, and then you have string characters. Example of string characters is like this quotation, this sequence of characters enclosed in this quotation. When you say a character, you are referring to just T alone, or this quotation alone. Character is a single value. But when you now combine everything together into sequence or strings, you call it string. So it's a string of different character. That's just a crash course about data type, and then um, numbers and characters. So guys, we are done already with our value. You can see that there is even something we can say. We can, okay, we are done. Let's just print what we have here. So we have, this is going to be the output. Num1 equals this, num2 equals, num3 equals, num4, okay, num5 equals, okay. And then we are now saying the average of num1 plus num2 plus num3 plus num5 equals this average. You know, we have the variable sum. We can find a way to coin this English here. The average of num1 plus num2 plus num3 plus num5, or we can say the sum of num1 to num5 equals, reference the sum that we have here, and then average, still put another printf for average, but we don't need that. Let's just go with what we have here. So let's run, and hopefully let's check our code from top to bottom. Compiler runs code. Compiler processes code from top to bottom and left to right. So we have the comments, and it's a multi-line comment. Don't forget, the comment is optional to the way you really want to write it, but this is like one of the standard ways, okay? And then we have the header section, okay? And then we have our declaration section here, okay? And then we have our main section. At some point, don't forget, this declaration section that we have at this point here could come in here too. Don't forget that. So, but some of the time, because why we have here, this is obviously the global, is used for global declaration, whereby values that appears here are values that are meant to be used often and often and often and often. You understand? So that's why they call it global. I could believe that when we had today class, the today tax, when we read the materials, the concept of variable was being introduced to us, where we had the local variable and global variable. So we could understand local variable, understand global variable, and we will still treat it here when we move. So we have the main function here, and then we have our variables being initialized, and also we have our logic being what given here, and we can say initialize variables. We can have code logic, okay, and then we have what the printing out, and we have a return value. If it returns 0, it means it is successful. If it returns another value, then something is wrong. So to save all the talk, let's run the code. And here we have it. We say num1 equals 2, and we have, as we printed it here, you can see that every of the output was according to the value. Num1 was 2, of course. Num2 was 15. Num3 was 25. Num4 was 10, and Num5, excuse me, was what? Was 13. And the average of Num1 plus Num2 plus Num3 plus Num4 equals 13, as given here. Now let us verify. Let us see the total sum. We can say printf sum equals, we can then reference %d and reference sum. Okay, so we really want to see the total value. Okay, so we can run. Now this should be on a new line, so that it won't, if you look at what we have here, although this did not show it, but we see the total sum. Okay, from here, total sum is 65. You can see that there was no space and the next line followed, because there was no new line. So adding the new line syntax breaks this man down to the next line. So total sum is 65. This n is coming from %dn that I wrote here. So guys, we have been able to see, we use some kind of stuff here. We used the printf function, and we could try understand some of the format specifier. We call this format specifier for integers, %d, and so on. So we've been able to do our assignments. So we can see that 65 divided by 5 is obviously 13, right? If we do the mathematics. So this is actually correct. And now there is something that happened here. This value was printed in decimal. And I like what the Sheriff did in the first place while he was declaring the what? The variables. He assigned that the what? Each of the integers, each of the individual numbers, that they are integers. Each of the individual numbers, they were integers. Okay, even some can be a float, because at some point you could have uh, in fact, everything could be a float if we are dealing with capturing even real numbers. So sometimes floating point numbers are called real numbers. That is, at some point in reality, we could have to calculate average of numbers with fractional parts, numbers with decimal. You understand? So, but looking at it here, he captured all of the individual numbers as integers, whole numbers that does not accept decimal. And then the floating point should be an average in case there is a division that happened from what each of the from the addition of individual numbers from the sum and what the total numbers. Peradventure we have something like 2 here, and although this is not correct, we are going to be having, okay, I don't know what number will give us odd number. Let's say 3. Will 3 give us? No. Let's say 7. So we should have decimal. This is 9. I don't know. 65 divided by 7. I don't know the math too. So I think everybody.
Okay, how about we change one of the numbers themselves? Maybe instead of 15, let's have 16 or something.
Okay, let's add 16 here. So we are going to be having 66. Okay, so 66 divided by 5 should give us, okay, we are having 13 as a value, but let's see.
Is it's not printing out the decimal number.
You said?
The program is not printing out the decimal number.
I can't hear, but I think she said the program is created. I didn't hear the
No,
last.
not not printing out the decimal number.
Yes, yes, actually, what happened, there's a conversion that happened in the first place. If individual numbers, each of them had been a floating point, okay, then when we do the division from here, it will accept floating point. And also, yes, that's just the point here.
Hello, hello,
Okay.
hello. I think it is actually this online thing that is making all these things impossible. I tried checking with my, I used
Com
these code blocks again, and it worked. It gave me a floating point.
okay.
Like, yeah.
Okay, so it's the compiler then. Thank you for that. Thank you for that clarification. Okay, okay. So we are good to go already. So guys, the assignment has been done, and we just let's move to what we have. How many minutes have we used? We've used 1 hour already. We've used 1 hour already. Let's quickly go to the topic for today. We've been able to do this assignment. What matter most in this assignment are the logics that we want to and the concepts we want to grab. Okay, so in fact, part of this we've spoken about it, but let's just talk about basic concept of how we write, thinking like a programmer, basic concept of on how we write program codes. We need to understand that in order for us to write a code, set of instruction to perform a specific task, it is very necessary for us to understand the basic syntax, that is the acceptable symbols or characters, and also the semantics. Semantics give meaning to syntax. For example, A plus B is actually a semantics that is defining or describing the acceptable syntax or symbol for writing a program that we add two variable A and B. So understanding the semantics, and also even part of the semantics starts from the proper way of writing a variable or declaring a variable, sorry, the proper way of doing something. And so semantics talk about how the proper way of how these things are being done, while the syntax talk about the actual symbols or characters that are used for what, for doing it, for writing the code. Be referring to what we did previous time, the syntax there, we could talk about each of the various syntax, talking about um the syntax, like syntax for writing the comments, syntax for writing an include file or another file, the syntax for declaring the variable, like using the int, you must have the data type and then the name of the variable. Those are like syntax, each of the same. So when you now declare it very well, when you now declare it in the actual sense, that is what semantic is. For example, when you are against the semantic is when you now do something like probably int a equals int a equals 1, comma int b equals 2 3. Like this semantic is wrong because it is not acceptable. This way, the actual way of doing this is not available because we are trying to say int a equals to int b equals 2. So that's what like semantics means. So acceptable semantic is that okay, if you are declaring variables in one line, then this int, as long as you have used a comma separator here, it covers all whatever variable that comes on that line. So when you have int a equals 2, comma b equals 2, you are trying to say int a equals 2, comma int b equals 2. So you don't have to do int. So that is just one thing. That's not what we are going to. So semantics. Now we can say syntax is about the form of a code, how the code would look like, while semantics is about the meaning of the code. So when your semantic is against the defined rule of a particular language, then there will be error. There will be semantic error. We have different type of errors in programming. We have syntax error when you use the wrong syntax. We have semantic error when the proper way or the logic you are trying to coin different syntax together is wrong. We have compiler error. We have um, we have user and so on. I just forgot them right now and I remember them. So all different type of error, semantic error. We have logic error too. Okay. So for example, if we need to create two variables that will hold two different numbers, such that we can later do something with those numbers. To do this, first we need to know the acceptable syntax of that programming language that can allow us to create variables, give or assign values to the variables. We need to understand the acceptable syntax that will allow us to do this. We need to understand that will give us or assign values to the variables and also allow us to do something with the variables. For example, print out or manipulate them. So that is just one of the things. As being like a programmer and as someone who is about to write programs, you need to really understand. That is why we did that. Our first algorithm pseudocode, whereby we defined all of the steps. So now, for example, creating a variable in C, we first need to understand which type of variable we need. Okay, is it a number? Is it a string or character? Or is it an array or any of that we have stated before? There are more data types. So one take home from this point one is when we are creating a variable that we want to use to do something to hold a particular value, we need to know what type of value the variable is going to hold. It is by the type of value that the variable is going to hold that will determine the type of variable we are going to create. Okay, so when you are buying clothes, you need to know the person that is going to put on the clothes. Is it a male or a female, or probably an animal or something? So trying to understand that will tend to give us understanding of how to create the variable, or how to buy the clothes, or which clothes to buy. So for example, we have already talked that I've even said many of these in the crash when we are having the assignment. If it's a number, we have different type of number. As I said, we have integers or whole numbers. We have floating point numbers that accept decimals, fractional part. So we have, for a number, we have integer. The syntax for this in C, int, the type of data, which is int, specifying integer, and then the name of the variable. We have done this. Or if it is a character, then the syntax is char, C-H-A-R, and then the name of the variable, which can be defined as type of the variable and what the variable name. So these are just crash because when we still get to variables, we will still really understand. So when we look closely at the codes, we could see each symbols or words, that is syntax, that describe the creation of a variable in C. Each of these syntax one by one are called tokens, of course. That is, int is a token, even the comma is a token, a is a token, if the assignment symbol operator is a token, and the individual constant numbers are token, the terminator, semicolon, they are all tokens. So these individual symbols are token. That is why when you run a program and let's make an error somewhere, probably I forgot to close this man and I run it, there's going to be an error somewhere. And based on the compiler though, I was expecting that some compiler will tell you error expected token, and they will specify the token. After then they will give you the description. So understanding that every of these symbol individually, from the parentheses to whatever is on the screen, they are all tokens. Okay, so we've talked about variables and constant, crash like the last time, but let's dive into it. So variables and constants. Variables, or a variable has a name and a value. So a variable is anything that has a name and value. They are containers or identifiers. That is anything that we can identify with a name. That is why we say variable, they have a name and a value, which has a value. So variables, anything to use to identify a particular thing. So it is you can call it a variable, but and also it must have a name and it must have a value, or the tendency to hold a value. So variables have the tendency to change. So one thing about variables, as based on the name, the word variable comes from what we call vary. It varies. It has tendency to change. That is, can be assigned another value during a program execution. So its current value has a tendency to change in the course of executing the program. So the acceptable ways of writing variables in almost all programming language. This is necessary too, because while we are trying to create variables, probably as we go on in C, there are some syntax, or there are some rules that governs the creation of naming variable. Okay, so we have this conventional system called camel case system, whereby you have the first letter as lowercase, and then if you are merging two words together, the next word that comes becomes a capital letter, just like you have first name, last name, calc birth year, that's calculate birth year, calculate average, and so on. We have the other one underscore in between variable names, and it's called snake case, where you have something like first name, last name, calculate birth year, and so on. We could have seen all of this in Linux. These are mainly used by mostly Linux user. This the above one is mostly used by JavaScript users and probably PHP. And then we have the other one we call flat case or letter case, where everything is just lowercase, no matter how you use it. So, but sometimes it said it could confuse when you have longer names. Then we have the other one, uppercase first name, and this one are mostly used sometimes for constants. Okay, so another features of variables can contain numbers, but they must not have spaces. We have, as you can see, it can contain numbers. We can have name 2, name 3, and so on, but they must not have space. Having space, you have separated them. So there are two separators. We have comma separator and space separator. So sometimes when you put comma in between if tokens or syntaxes, you are trying to tell the compiler or the shell or the development environment that you are separating these values, or even if you put space. So variables cannot start with digits. So this is wrong. One, name. Two, calc. And variables cannot have hyphen in between them, just like this. These are just based on overview. When we come to variables in C, creating variables in C and constant, we will see how this really work deeply. So we have constants. Constants also have names and value. They are also containers or identifiers. Okay, anything we can identify them with. So they have name and value constants. But by the name, constant cannot change its value once it is assigned. We call them like constant, they will have to remain the same without changing. So when creating constant, they most times are given special way of creation, which we talked about. You see, uppercase, where you can create constant saying const int pi. Even this is wrong, it's not int, float pi. Okay, so because this is a floating point number. So you can see, and other languages, they have different ways you can create their constants. But majority in C, to be specific, is that constants actually start with uppercase. Why are we doing all of this? Is majority for the majority or in among us, the beginners, and just to carry everybody along. We could just dive in and start writing all of this, but we just need to get the basic. By tomorrow, we will dive in better. So data types. Now that we know variables and constant, it is now time to understand what we call data type. As we all know that variables or constants are used for storing different types of data. That is numbers, letters, strings, arrays, or objects. It is therefore necessary that we know the different types of data. Okay, we know the different types of data or different data types as far as C programming is concerned. So we we have different data types. Now, one thing that is special that we need to really understand as C is concerned, because when we start it, most of the question that they'll be asking is size of this data type, size of an integer, size of a floating point number in the 64-bit or 32-bit machine, size of a character. Size of data matter very more. They matter very more in C, because C being a language that is closer to the machine level, it focuses more on you defining whatever you define explicitly, that you know what you are doing, and also having making sure that you have understanding of what you want to achieve. If you are creating an application that requires enough numbers, that's going to be dealing with a larger amount of numbers, then C is expecting you that you use probably double, which has tendency of containing a larger amount of numbers, to what, as the fundamental data type for your numbers. So data types in C language, they have different meaning and they have different amount of space they occupy in the computer memory. So as it being an integer has its own size of memory, amount of memory it occupies. For example, let's just particularize something. I'm going to comment out this logic that we have here. Okay. I'm gonna comment out. I'm commenting out this one too. So in C, there is an operator called size of operator. Okay, it is used for printing the size of type. You can see expression of type. This is for printing size of different data type in different machine. And now size of data type varies in in machine. Okay, so you can say size of, you can say printf, and you are trying to print size of an integer. I don't really know what methodology this online compiler is using, so I wanted to specify in a 64-bit machine. Obviously my system is a 64-bit. Okay, so but you can see size of an integer in a 64-bit machine, and you can now say equals, then we do percent %d because we are printing an integer. Okay, there's another operator for integer too. If you don't want to use percent %d, you can say percent %i. So but we are using percent %d. Okay, so we can do that, and then we reference the size of operator, and we put int. So we are referencing that we are printing the size of an integer, and then we close this operation here. Okay, even when we get to data type very well, we have something, we have long int, we have short int, we have unsigned int. So this compiler is just trying to ask for too much things. Normally when you don't specify probably sign, like what you are seeing here, when you don't specify sign or unsigned, long or short, automatically it is a sign like this. When you now specify unsigned, then you are actually um being specific. So when you print this now, we should see, you can see size of an integer in a 64-bit machine is given 4 here. I said I don't know the methodology this compiler is. Probably is referencing my machine. So 60 is 4 bits, 4 bytes, sorry, not bits. Okay, so 4 bytes. If I go on and say printf size of a float, now we did just specify sign float or unsigned. We might not know what that meant, but when we get there, size of a float in a 64-bit machine. So for float, we are referencing f, and then we do, I do not put a new line here. Okay, and then add a new line here so that it won't get like that. Then we do size of, and then we say size of floats. So right now, this should give me the size of a typical floating point number in a 64-bit machine. Let me copy this and then let's do for double. I'll do for character so that we can have different values, because float could be 4 bits too. So let me make this one, let me make this one character, so a car, and let me make this one this double. So size of a float in a 64-bit machine, size of a character, a car is a 64-bit machine. Now for character, we have to specify, the format specifier is %c. This looks strange, but we'll get to know them soon. Then we have size of a float in a 64, in a double in a 64-bit machine. And when we are referencing double, we say long float or LF. So we should see the values. Now, size of an integer in a 64-bit machine, 4 bytes. Size of a float in a 64 bits, giving 0. Okay, this compiler. Okay, probably there's no need to declare. I don't know. It's A, ca B, ca C, float P, and double E. Okay, so let's put the value A, float P, C, size of C. So we are referencing the variable we created, okay, and double E. Okay, so size of A, size of B for floats, size of C for character, and size of E. And so obviously it is this compiler. It is this compiler, and I could have opened my code blocks. So I'm just trying to reference that each data type, they have their value, that the amount of space that they occupy. So data type tells you the type of data you want to store in memory. Maybe you want to store a number, integer, decimal, or maybe you want to store a string or a character. So when data types are specified, the compiler reserves the required amount of bytes needed to store that data, type in memory. So compiler focuses more on the amount of space in bytes. A byte is actually um, a byte is 8 bits. I will try as much as possible. We have a section on number system. This is very necessary, especially when we get to bit manipulation in C, where you have to do bitwise operator. You do left shift, right shift, and left or bit or x or and so on. All these things, there are formulas for calculating them, and they are necessary. Okay, so why do we have data type? To know the type of data to store in memory, and also so that the compiler can know how many space to reserve. So types of data type, we have basically um, three types of data type. We have primary data type, we have derived data type, and then we have user defined data type. So primary data type, what we call it built-in, which we have int, float, char, double, and void. And then we have derived data type, where we have array, structure, union, pointers, okay, and user defined. We have type def and enumerate or enum. All of these things are things that we are going to come and practicalize with. But what matters most before practicalizing anything, you need to know that thing, that it exists, and you need to have understanding of what category it belongs, what function it performs, or what it does. That is why we are talking about data type and trying to speak about it. So this is just what we have for today as regards our agenda. Then to round it off, let's talk about something called SCANF. We did an intro with Printf. We have been using Printf all this while. Now let's talk about SCANF. So SCANF is actually used for SCANF is used for receiving inputs from user. Okay. So SCANF, okay, to receive inputs from the user. So most of the time, we say we want to calculate average of 5 numbers. We were the one that declared the numbers. So sometimes We were the one that initialized the numbers, the values for the variables. But sometimes if it involves that you want the user to provide the numbers, you can use scanf to receive input from user. So scanf actually receives input from user, and it's and for numbers, it actually reference the address of every given integer or number. Like you see, probably example, you have an integer declared int a b c, and then you now say printf, please enter three numbers. That is to prompt the user, okay, by using scanf, then printf. Then you can now use scanf to receive each of the numbers from the user. So with scanf, you can reference each of the numbers by saying and a. Sorry, you can say percent d, that is for the first number, percent d for the second number, and percent d for the third number. And then you can now reference it saying and a and b and c. All of this looks strange, yes, but it is always good that you have a taste of what you later have full taste of. Sometimes it helps you to get along. So this is like the structure of how the scanf work on numbers, integers to be specific. So when you are trying to use this, if you use this like this line this line will run after the header files from the comments. Comments are always neglected by compiler. So getting to the header files, entering to the main section, and you declare the variables, then this line will run printf for prompting the user, please enter three numbers. Then it will now come to this line. It will give the user access to the screen to input value. So the user input the value, each of the value. And what is happening here is that every value that is inputted from here is stored into A. That is where this AND is talking about. We are referencing A. And for this second value imputed, we are referencing B, that is storing it inside B. And then for this value enter, we are storing it inside C. This AND is like trying to get the address of A, B, and C. On a normal ground, all of this I'm still saying it's like there are basic things that will still really dwell with as far as C is concerned. For every variable that is being created, they have what? They have memory. A memory is assigned to them. An amount of space is assigned to them in memory. Okay, so if you have like this int A, B, and C, how is the space assigned to them memory? According to their size, their space is assigned to them in memory. So if you say 4 bytes, if you say 4 bytes, that is about 4 bytes is telling you that we have one a sorry, a byte is 8 bits. Okay, so when you now say 4 bytes, a byte is 8 bits and you have 4, that means you're about reserving like 32 space, 32 bits, okay, inside the memory. So what I'm trying to say is, for every of the what integers, for every of the variables with their type, with respect to their type, they have amount of memory space given to in their memory. And now, but that they have an amount of space given to them in memory, it also tells us that each of them, let's say A is stored in this space, B is stored in this space, and C is stored in this space. Okay, so now what we need to understand is, remember, this is 4 bytes, 4 bytes, 4 bytes. Let's assume, suppose that the size of this integer in according to the machine is giving it 4 bytes, 4 bytes, 4 bytes. So what you need to understand is that For this 4 bytes, for this each of these variables given amounts of amount of reserve space in memory, it also has a position or location. Okay, let's assume each of them is aligned this way. Okay, so you need to know that, let's say this is position 1, position 1 for A, position B2 for B, position 3 for. So this location, this address, the location we are talking about is like address for this man, this man. So address could be something like, you can have, let me expand this. All these are overview. They are not something that I just know that something like this exists. Okay. When we get there, it will become more clearer. Address could be like, okay, you can have something like 0x A, B, and so on, 3, C, E. And you can have another thing like that. You can have 0x0001. Something like this, telling you that it is a location. So this address, this AND is collecting the address and storing it into referencing the address of A and storing the value given by the user into A, by the second input into B, and the third input into C. The ampersand, this is called ampersand or and symbol, is used for referencing address. Okay, so scanf, just a basic overview of this is how it works. When we get there, it become more clearer. So guys, you can practicalize the scanf. You can just do something. We are calling it a day now. We are done. We can say, okay, so let us work with this int A, int B, int A, int A, B, C. So you can now say, we want to add 3 numbers. You can now say printf, please enter 3 numbers on a new line. What do? We now have to reference scanf. So scanf, you can now say %d for first, %d for second, %d for the third. So I can add every of them on a new line so that it will always drop down. And I can now reference ampersand A, ampersand B, ampersand C. That is referencing the address of A, B, C. So right about now, I can now say, let me declare sum. I can now say sum. I can say printf. I can do everything here. I can say A plus B plus C, or I can say sum, just strings. Sum equals A plus B plus C equals, I can now reference, %d for sum. I can now say, I can still put it this way. These are just strings. %d plus %d plus %d. So this is inside the string. This will be printed out. So I can now reference what each of this. I can say sum equals A plus B plus C. Now look at it. Look, this sum here is for this %d. This A is for this %d. This B is for this %d. This C is for this %d. To make it clear, I can put a new line here. I can say equals new line, and this will drop down. So if we run this, so now Please enter three numbers. It is waiting for me to prompt. The SCANF has one. So first number is 7, second number 8, this compiler. Last number 5. Okay, is a network. So if I run 8, the network, let me run it again. So first number is 8. Oh, network is bad. 5, 6. So it's supposed to print this line, Printf. Okay. So the logic is this man, the values of this will be what? Reference, and this is supposed to be printed out. Okay. Probably there's no error anywhere though. Even my numbers are taking time to appear. So guys, we just have an overview of how the SCANF work. You can see at least I have the ability to type in from here. So this gives us idea that SCANF is for receiving input, although it has limitation, but at the same time we are able to get what we are trying to look at. Let me see for the last time. Okay, it is just this compiler is giving issue. So guys, let's call it a day for now. Other persons have already gone off, but at least I think we have been able to learn some basic things so far. We are going to dive in better. All of this concept of memory addressing, pointer, address, location, they are very, very, very necessary because that is one of the key things that C is being founded upon, understanding pointers, and it's we are going to get skill through. So um do anybody have any observation, suggestion as we call it a day for now?
Not at all.
All right.
No suggestions yet. So thank you.
All right, guys. Thank you for joining today. We hope to get something more. We are going to get deep dive better tomorrow. Okay, so dive deeper tomorrow. Okay. So thank you for joining and have a good night.
Thank you
Bye.
so much for your time.
All right. You're welcome. Good night. Bye, everyone.
Good night.